We have this augmented leads, which is AVR, AVL, and AVF. Okay? And then dinagdagan pa natin ng chest leads, V1, V2, V3, V4, V5, V6, and it creates the 12-lead ECG. So it will give us a picture of the heart. So the limb leads, 2, 3 EVF, AVR, AVL, and 2, 3, 2, 3, 1, 2, 1, 2, 3 AVR, AVL, and AVF. It's cutting the heart in this ano ba plane to? Longitudinal plane ba to? Yes, longitudinal plane. So we are able to have a picture of the longitudinal plane of the heart. While the chest leads, it's cutting the short axis plane of the heart. And so, kasi dito siya nakalagay sa chest lead. So it will give us a picture of the short axis of the myocardium. Okay, so there are electrodes. It is able to produce, say, for example, lead 1. This is between the potential difference between the left arm and the right arm. So the positive electrode is on the left, so right arm, left arm. So the positive electrode is on the left. So if the electrical impulse is moving from right arm to left arm, it will produce the meter to move to the positive deflection, and the pen will move up. So ganun na yun, diniscuss natin kanina. So ganun lang din ang ginagawa sa lead 2. It's between the right arm and the left leg. So the positive electrode is on the left leg, and the lead 3 is between the left arm and the left leg, and the positive electrode is on the left leg. Nang student ako, nakakaloka talaga yung kaka-memorize nito. Bahala na kayo paano nyo i-memorize. Ngayon na in practice, hindi na namin siya pinapakialaman. Saksak lang naman kami agad ng yung mga nurses dyan, alam yan. Hindi naman lang kayo nagme-memorize ng mga positive, negative. Parang nilalagay na lang namin yung mga limb leads at chest leads and do the ECG. Ganun na siya ka-easy. But since first year kayo, we just try to discuss the basic. All right. So the augmented leads naman, pag sinabi nating AVR, that's the difference between left arm and left leg to the right arm. Ganun din sa AVL and AVR. And so we are able to produce this hexaaxial system. So ganun na siya. This is lead 1. Lead 1. And then this is lead 2. This is lead 3. And then this is AVF. This is AVR. This is AVL. Okay? So, hindi pa siya nag-make sense sa inyo, but nagagamit namin to if we are going to measure the axis of the patient based on this hexaaxial reference. So, let's go to chest leads. You just put the leads on fourth intercostal space, the V1 on the right precordial area, fourth intercostal space, and V2 on the left, fourth precordial area, left precordial area on the fourth intercostal space. You put V3 on the fifth intercostal space, mid-clavicular line, and you put V3 in between V2 and V4. And V6, you put it at the axillary line, V at fifth intercostal space, but axillary line. And then you put the V5 in between V4 and V6. So common mistakes sa mga nurses, they sometimes put the V1, V2 at second intercostal space. And then the chest leads, the V3 to V6, is they put it on the fourth intercostal space. Kaya nagkakaroon na ng changes sa mga ECG mo. And then nahirapan ka nang mag-analyze. And sometimes when there are changes on the limb leads, nagkakaroon na ng magkakaibang picture na naguguluhan na. So as a doctor, you also have to know and analyze ano ba talaga yung normal picture ng isang lead, para if there is an abnormality of the deflection of the PQRST waves, malalaman mo na baka wrong lead placement. Because B1, B2 will show a large S waves. Again, the vector of the ventricular impulse is moving towards here. It's moving to the left and inferiorly. And so it's somehow away from B1, B2, kasi nandito ang B1, B2 ko. Kung papunta doon, it will produce a positive deflection in V5, V6, kaya nga mataas uh, yung it will produce large S wave sa kanila. But in V5, V6, it will produce in V1, V2, it will show a large S wave, while V5, V6, it will show a large R wave. So, di ba, R wave is an upward deflection. Since the vector is moving towards V5, V6, kaya nga R wave, mataas yung R wave nila. While it's away, a little bit away from the V6, kaya nga meron kang large S wave. So, I will show you examples of QRSS in V1 to V6 to 3 EVF in the next lecture. So, ito lang yung summary. You have to somehow memorize the location. Yung limb leads, madali lang kasi nalalagay mo lang yung tatlong electrodes sa right arm, and left leg. Tapos, depende kung nagka-capture ka na ng lead 1, ibig sabihin, ang magpa-function is the right arm and the left arm electrodes, where the positive electrode is on the left arm and the negative electrode also is on the right arm. So, ganun lang siya. And then, magme-measure ka na ng lead 2, lead 3, EVR, EVF, EVL. So, ganun din sa chest leads. Sa chest leads, you are putting the chest leads here. So, the positive electrodes are on the limb leads and the negative electrodes are on this chest leads. So, if you are going to measure V1, for example, the positive electrode is on the limb leads and the negative electrode is on the chest leads. But you have to properly put the electrodes on exact position. Kasi pag pinalit mo yung dapat sa right arm, napunta na sa left arm, kung magme-measure ka na ng lead 1, di ba dapat papunta doon? Nag-gets niyo ba yung point ko? Di magiging opposite na, and then the deflection of the waves will now be opposite and abnormal. Kaya kailangan mong alam yung normal picture ng all ECG waves. Okay, so this is the importance of looking at the hexaaxial system because the normal axis is from -30 to +10. So, ang tinuturo ko sa students to make it easier is you just look at lead 1 and lead 2. If both are positive, meaning upright, and automatically the axis is normal because positive ang lead 1 mo and lead 2 mo is positive. Therefore, the axis is just between 0 to +60. So, normal yung axis mo. So, that's how to make it faster. If you look at ECG, you look at lead 1 and lead 2. If both are upright, automatically the axis is approximately between 0 to 60. Nakukuha niyo ba yun? 0 to 60, meaning positive yun, confident ka. That's so accurate. If both the lead 1 and lead 2 is upright, meaning positive ang lead 1 and then positive ang lead 2, the axis will fall just in between either 0 hanggang +60. So, it's a normal axis. But, if for example, lead 1 mo is positive and lead 2 is negative, tama, negative, so somehow the axis will be between 0 to -120. Kaya baka maging, if it's beyond 30 degrees, then magkakaroon ka ng left axis deviation. Now, if the axis is deviated naman towards 110, then magkakaroon ka naman ng positive right axis deviation. So in this example, ang ginagawa niya is you have to measure the QRS. Makita. So, for example, this is 5, 6 small squares and this is 2. So, lead 1 is upright but you have, kailangan mong ibawas yung downward deflection sa QRS. So, kung 6 small squares and then dalawa naman yung pababa. So, 4 na lang. So, this is +4. So, 1, 2, 3, 4 you put here. Positive yung lead 1. And yung example nyo dito is lead 3. So, yung lead 3 naman is more negative. Pero dalawa lang sa taas, ilan naman to? Dalawa sa taas and then 5 pababa. So, -3. So, lead 3, lead 3, positive dito, negative doon, so lead 3 dito. And then you put the point in between the two, kaya negative 15 siya. So since negative 15 degrees siya, is still normal kasi ang abnormal is from negative 30 to positive 110. Alright. So, nakakaabala tong mga annotation sa aking paningin. The normal axis is not 110, sorry, negative 15 to 100. And then left axis deviation is if the impulse is negative 15 to negative 90. So negative 15, I'm sorry, it's not 30. And then the right axis deviation is parang tanga lang, no? Positive 90 naman. Let me just help you. Kasi in other books, it's 90. In other books, it's 110. So, paano ba tayo? Let's make it 100 to negative 15. Oh, para sa exam. Pantay-pantay tayo. So in other books kasi 15, yung other books 30, but let's make it negative 15 to 100. Yung ibang cardiologists, ginagamit nila pag more than positive 90 na, nira-right axis deviation na nila. Ako, 100 yung ginagamit ko. So let's make it negative 15 to 100. So indeterminate naman pag negative 90 to 100. So for example, if the axis is towards the left, think of left ventricular hypertrophy. And if the axis is more towards the right, think of right ventricular hypertrophy. Kasi nga, if, for example, the RV is enlarged and thickened, so the axis, the vector will move to the right. So the axis, the overall axis will now move beyond 100. So it will show a right axis deviation. And if the LV is dilated and hypertrophied, it will move the axis towards the left, farther more to the left, beyond negative 15. And so it will show a left axis deviation. So it's also helpful to look at the axis because it can give us analogy or analysis of what's going on to the heart. If there's deviation to the left side, then something is wrong with the overall movement of the vector, meaning if it has moved to the left, probably there is left axis, left ventricular hypertrophy, and it moves to the right, probably there is right ventricular hypertrophy. The end! Question. Ang hirap ng ECG. Nahirapan ako sa cardio.